Okay, last time we were talking about sections 3.4 and 3.5, and we learned how to factor a polynomial of higher degree. And also at the end we talked about the complex zeros of polynomials, and we said complex zeros comes in pairs. Pairs means as wedge. Of course, this is true if the coefficients of the variables are all real. Today we will continue with this same section to continue factoring polynomials. Then at the end we will talk about a theorem called Descartes' rule of signs. So let's look at this example here. He says factor f of x into linear factors given k is a zero of f of x. Our polynomial now is of which degree, ya shabab? I think this is degree 4, right?
Yes.
And he said k is equal to -2. K is what here he said is the 0. So -2 is a 0. And the multiplicity of -2 is what?
Two.
Of multiplicity 2. This means we will see this 0 how many times?
Two times.
2 times. This is the meaning of multiplicity. We see the 0 2 times. Now, to find the other zeros, we have to divide the polynomial by 2, or by x minus 2, of course. But since he said the multiplicity is 2, we will make the division 2 times because of the multiplicity. So if the multiplicity was 3, we will divide 3 times, etc. Let's start dividing now. Let's put the coefficients now. We have 1. Do we have any missing power?
No.
So if we have a missing power, we said we should put what for that missing power?
0.
0. Now let's start dividing. We said 1 goes down. 2 times 1 is 2. 2 plus 2, 4. 2 times 4
8.
is 8. -7 plus 8 is 1. 2 times 1 is 2. -20 plus 2 is 18. -18. -18 times 2 is... Sorry, this is I have to divide by -2, not 2. Sorry. Let's start all over. Not 2. I'm sorry. We have to divide by -2, Ishabel. So put 1 down again. We have -2, then 0, then 0, -7, 14, -6, 12, and of course the remainder is what?
0.
And we said this remainder is like a checking point. If it's not 0, this means there's something wrong. Then we divide one more time by -2. We have 1, -2, -2, 4, -3, 6, and again, what do you see about the remainder?
0.
It's also 0. Of course, we are dividing to find this factor. This is our other factor. So we will say f of x will equal to what now? X plus 2, which is the factor that is given to me. But what's the power of that factor? Is 2 multiplied by what? By the green one. And this green one is x squared minus 2x minus 3. Why? Because -3 is the constant, if you remember. -2 is the coefficient of x, and 1 is the coefficient of x squared. And of course, we can factor this green one more. How can we factor this? X squared is xx. And -3, we can say this is -3 plus 1. So this is our polynomial in factored form. Now, if I ask Shabab, what's the power of x inside each bracket?
1.
So we say these are what? Linear factors. Because the power of x is 1. Now, what are the zeros for this polynomial? We have -2, 3, and... And how many zeros do we have right now?
3.
We have 3 zeros. And if you remember, we said last time, the number of zeros of a polynomial is less than or equal to the degree. What was the degree in this question?
4.
4. So the number of zeros is less than or equal to 4. And of course, it will be greater than or equal to 1. So the number of zeros is between 1 and 4. If you have a question, raise your hand. Okay, some of you are not opening their cameras. Open your cameras, Shabab. Let's see this example now. What does it say? Find a polynomial of least degree having only real coefficients with zeros that are given. How many zeros are we given, Shabab?
3.
I think we are given 3 zeros. But now he says real coefficients, and one of the zeros is complex. We took a theorem for this last time. Can anyone remind us with that theorem? What is it? No one? Let's. This is our theorem. We call it the conjugate zero theorem. What does it say? If f of x defines a polynomial function having only real coefficients, and if z equals a plus bi is a zero of f, then a minus bi is also a zero. What does that mean, Shabab? If one of the zeros is complex, automatically the conjugate of that complex is also a zero. And this will only be true if we have real coefficients. So in this example that we are starting with right now here, are the coefficients real or not?
Yes.
The answer is yes. Do we have a complex zero?
Yes.
I think yes. So automatically the conjugate of this complex zero is also a zero. So what's the conjugate of 2 plus 3i?
2 negative 3.
So I will say 2 minus what now is also a zero of f of x. So in total now, how many zeros do we know?
4.
I think we know 4. Now the question is asking us for what? Find a polynomial. So he wants us to find the polynomial. So to find the polynomial, we did this also last time. I will open a bracket. And how many brackets will we open right now?
4.
4 brackets. Why? Because we know 4 zeros. And inside each bracket, what will I write? X minus. And of course, I will start with the real ones now. I will say this is 2 plus root 3. I have to put in brackets. And 2 minus root 3. What about the complex ones? I would have to say 2 plus 3i and 2 minus 3i. Now, of course, he says in the question of least degree. Least degree means the power of each bracket should be
1.
the least, which is 1. Now, our mission is to simplify this. How can we multiply, Shabab? Pay attention now. This is a rule that we have taken earlier. How can I multiply these? There is a rule that we have taken for this. The rule, if you remember, I'm just going to write it here, says we have x squared minus the sum of zeros multiplied by x plus the product of zeros. This is the rule. If I apply it now, who can tell us what's the sum of the real zeros, which are 2 plus 3 and 2 minus 3? If we add them, what's
4.
the answer?
4.
4. So this is x squared minus 4x. What's the product of them? If we want to multiply 2 plus root 3 times 2 minus root 3, do we know how much is the answer?
Yes. 4 negative 9.
4 minus 3, which is 1. Because the square of 2 is 4 and the square of root 3 is 3. So this is the product of the first two factors. In the same way, Shabab, we can multiply the factors containing the complex zeros, which are these. We can use the same rule. So we will say the following. This is x squared minus the sum times x plus the product of zeros. Now, what's the sum of them? When I say 2 plus 3i plus 2 minus 3i, how much is that sum? I think it's also 4. But what about the product? 2 plus 3i times 2 minus 3i. Does anyone know what's the product of these?
4 plus 9.
This is 4 plus 9, which is how much? 13. Now the remaining part is to multiply these. I will leave this part for you. I'm not going to do it. You need to multiply these in the long way now. You have to multiply x squared by everything. Then after you finish, you multiply -4 by everything. Then -4x, sorry. Then after that, we have to multiply what? 1 by all these. I'm going to leave this step for you. But the important thing, Shabab, is to know how to multiply the factors. Again, if you have a question, raise your hand. Ali Saba.
Yes, is this rule work with 2 plus root 3 also?
Yes, it works with any types of roots.
No, I think the conjugate.
The conjugates works with the complex and with the irrational. But in the case of irrational, the coefficients should not only be real, the coefficients should be rational. Again, if we have one of the zeros that is irrational, the conjugate of the irrational will be a 0 if all the coefficients of the polynomial are rational, if you like to take this theorem. Okay? But regarding the complex, the coefficients should be real. Regarding the irrational, the coefficients should be rational. Any other questions? Okay, sure. Done with this part. Let's move on down. Sorry, we are done with these. We have only one last thing to talk about in this section, which is this theorem. This theorem, what's the name of the theorem now? This is Descartes' rule of signs. Descartes is a mathematician. Rule of signs, what does that mean? He will talk about the possible number of positive real zeros and the possible number of negative real zeros. But before doing that, there are some conditions that we need to see. Let's read the theorem. What does it say? Let f of x define a polynomial function with what? Real coefficients. So this is the first condition. The coefficients should be what? Should be real. Let's continue reading. And a non-zero constant term. This is the second condition. So the constant term should not be 0. If it's 0, this theorem cannot be used. And the next condition with terms in what? Descending powers of x. This is the third condition. What does it mean, descending powers of x? Anyone knows the meaning of that? Descending powers of x. Descending means tanazuli. So the powers of x should be descending, starting from the highest power, going down to the smallest power. Now, in this case, what will happen? Let's read the first rule. What's the first rule? He says about what now? The number of what? the number of positive real zeros of f. So he wants me to know now how many positive real zeros do we have. Let's read what does it say. Is either equal to the number of variations of signs. Variations means change in the signs occurring in the coefficients. Occurring means appearing. Or is less than the number of variations by a positive real integer. Sorry, a positive even integer. Of course, you didn't understand anything here. Let me give an example to understand. Look at the example which is below. First of all, is this a polynomial?
Yes.
The function that is written, is it a polynomial, Shabab?
Yes. Yes.
طيب, let's look at the coefficients. Are these coefficients real?
Yes.
Yes. Our constant term, which is this one, is it 0 or non-zero?
Non-zero.
It should not be a 0. If it's 0, we cannot use this theorem. What about the powers? Are they descending?
Yes.
What's the meaning of descending again?
Three.
تنازل.
It means tanazuli. So now, are all the conditions satisfied here? The
Yes.
answer is yes. Now, the question is asking for what? He says determine the possible number of positive real zeros and negative real zeros. Let's start with the positive now. I will say the number or the possible number of positive real zeros. Now, Shabab, we have to look at the coefficients. If you look at from -2 to +3, is there a change in the sign between the coefficients? From -2 to +3, is there a change in the sign?
Yes.
Yes.
So I'm just going to say this is yes. Now I will count how many changes in the sign do we have. From +3 to -5, Shabab. Is there a change in the sign?
Yes.
The answer is yes. From -5 to +4, is there a change in?
Yes.
Also yes. From +4 to -1, is there a change in the sign?
Yes.
So how many changes of the sign do we have?
4.
4 changes. This means the number of, or the possible number of positive real zeros is 4. This 4 came from where, Shabab?
Change the sign.
The number of changes in the signs. But the theorem says what now? This is a possible number. It can be 4 or it can be 4 minus an even number. How much is 4 minus 2 now? Is 2. Or it can be 4 minus 4, which is how much?
0.
So if I ask now, what's the possible number of positive real zeros? We have 3 choices.
4.
We can have either 4 positive real zeros or 2 positive real zeros or what?
0.
0 positive real zeros. This means we have no positive real zeros. But the question is, Shabab, now, why do I subtract 2, then I subtract 4? Let me remind you with this theorem that we have revised earlier, this one. We said if one of the zeros is complex, automatically the conjugate of that zero is also a 0, right? If we have a complex 0, its conjugate is also a 0. And of course, this is only true for the real coefficients. What does that mean, Shabab? That the complex zeros comes in pairs. What does it mean in Arabic, pairs?
زوج.
Azwaj. So the number of complex zeros, they can be 2 or 4 or 6 or 8. They are what? They are even. So we cannot have odd number of complex zeros. Again, I repeat, this is only true if we have real coefficients. So can a polynomial with real coefficients have 3 complex zeros?
No.
The answer is no. Why? Because the number of complex zeros should always be what they should are.
Even.
Should be always even. Can we have two complex zeros for a polynomial?
Yes.
The answer is yes, but with the same condition that the coefficients should be
Real.
real. طب can I have four complex zeros?
Yes.
Can I have five complex zeros?
No.
No. So that's why in this example, what am I doing? I'm subtracting 2 or 4. These 2 or 4 talks about what? These 2 or 4 talks about the number of what?
Positive.
The complex zeros. I have to subtract even numbers. The complex zeros are always what?
Even.
Even. That's why I'm subtracting 2 or 4. So this is now the number of positive real zeros. We can have either 4 positive or 2 positive or no positive zeros. But can we have 3 positive zeros for this example?
No.
The answer is no. Can we have one positive real zero for this example? Or for this polynomial?
No.
Also the answer is no. So the number of positive zeros is either 4 or 2 or 0. Any questions about the number of positive real zeros before going to the negative? Raise your hand if you have a question on this. Now let's talk about the number or the possible number of negative real zeros. To find the number of or the possible number of negative zeros, we have to find f of negative x. We have to find this first. And what does it mean f of negative x? Replace every x by what? By negative x. Now if I replace it, will the even powers change their signs?
No. No.
Will the odd powers change their signs, Ashabah?
Yes.
So which terms from my polynomial will change their signs?
The odd.
The odd powers. So what's my polynomial now? I have to say this is negative 2x to power 4 minus 3x to power 3 minus 5x squared minus 4x minus 1. Which terms did we change the signs of? Just the odd powers. Why? Because negative raised to an odd power is negative. Now let's count how many changes in the sign do we have?
None.
From negative 2 Shabab to negative 3, is there a change in sign?
No.
The answer is no. From negative 3 to negative 5, is there a change in sign?
No.
No. From negative 5 to negative 4, is there a change in the sign?
No.
And from negative 4 to negative 1?
No.
So how many changes in the sign do we have here?
0.
We have no changes in the sign. This means the number of negative or the possible number of negative real zeros is 0. We have 0, negative real zeros. This means what we have? No negative real zeros. Why? Because there's no change in the signs. Any questions on these two? Now let's talk complex. We said how many complex zeros can this polynomial have?
Either 2 or 4 or 0.
We can have 0 or 2 or 4. And don't forget the rule that we have mentioned last time. The number of zeros of polynomial is less than or equal to the degree. What's the degree for this polynomial?
4.
Is 4. So the number of zeros is all as at most what? is at most 4 and at least. Do you know how many at least do we have?
3.
At least one. No, we said at least one. Any polynomial have at least one real zero. Now I will make a table about the possible number of zeros, including the complex. But let me first of all put them in a table. This is the possible positive or possible number of positive real zeros. Possible number of positive real zeros. And the second one is the possible number of negative. And the last one, the possible number of complex zeros. Now we said about the positive, how many do we have, Ishabab? Remember the one that we have mentioned earlier here? We said we have either what? 4 or what?
Or 2.
Or 2 or what?
0.
Or 0. What about the negatives?
Negative always.
We don't have any negatives. Type. What the sum of the zeros should be? What Shabab here? We said the sum of the zeros should be at most 4 and at least
1.
So I have to satisfy this rule. The sum of zeros is between 1 and 4. Now, can I have this case for complex, 4 real, 0, sorry, 4 positive, 0 negative, and 4 complex?
No.
This is impossible. Why? Because the sum will be more than 4. So can I have this possibility? 4, 0, 0?
Yes.
Yes, I can. So can I have this possibility now? 4, 0, 1?
No.
Why? We said the number of complex zeros is
Be-
always what?
Even.
Is always even. Can I have this possibility type? 4, 0, 2?
No, the sum should be less
The
than.
sum should be what? Thank you very much. The sum should be less than or equal to 4. So this is impossible. Type. What about the second one? Can I have 2 positive, 0 negative, and 2 complex? Is this possible?
Yes.
Type. What about this case, Shabab? 2, 0, 0. Is this possible?
Yes. No.
Why no? What's the sum of these?
2.
Type. Is 2 between 1 and 4 or not?
Yes.
So this is possible. But here I'm talking about the different zeros. Okay, Shabab? So can I have this possibility now? 0, 0, 2?
Yes.
0 positive, 0 negative, and 2 complex? Can I have this possibility? 0, 0, 4?
Yes.
So can I have this possibility now? 0, 0, 0?
No.
No. Why? Because we said the sum should be between 1 and 4. This is 0. So this is impossible. So again, I repeat, the sum of all the zeros should be between 1 and 4. And the number of complex zeros is always even. Any questions? Raise your hand. If you have no questions, we are done with this section. Now we will start solving some recitation.